Ready to dive into the world of clean code? We're going deep on your excerpts from Robert C. Martin's Clean Code and really pulling out the gold for our listeners.
It's a classic for a reason, right?
Yeah.
I mean, every developer I've ever met at some point has probably looked at their own code and thought, oof, could this be any messier?
It's like that junk drawer we all have, right? Like, you know it holds stuff, but good luck finding anything in there quickly or even remembering what's important.
Exactly. And one of the things that clean code really drives home is that writing clean code, it's not just about making it look pretty. It's about the impact it has on your productivity, your team's productivity, even the long-term health of the project.
Okay, so it's deeper than just aesthetics. It's really about the health of the code, in a way.
Yes, precisely. Think about it like reading a news article, right? A well-structured article. It just pulls you in. You can skim the headlines. You can dive deeper into the paragraphs that really grab your attention. And it makes sense. Clean code is kind of like that for your brain.
I like that, because if the code is laid out clearly, then I'm not wasting time like mentally untangling it all.
Exactly. And there's actually a fascinating parallel to this idea of like the broken window theory. This theory suggests that, tolerating even minor disorder, like literally a broken window, can actually invite more significant problems down the line.
Oh, interesting. So one messy bit of code is like giving permission for more bad code to creep in.
That's the idea. Yeah, messy code can snowball, leading to slower development, making debugging a nightmare, just generally increasing the cost of maintaining that code over time.
And I don't think anybody wants that, especially, when deadlines are looming. So how does clean code help us avoid those pitfalls? Where do we even begin?
It all starts with something that might seem surprisingly fundamental.
Don't leave me hanging. What's the secret weapon here?
Names.
Wait, really? Like variable names, function names. That's where it all starts.
Absolutely. Think of them as like the unsung heroes of readability. When you choose names that are clear and descriptive, you're instantly making your code easier to understand.
Okay, can you give me like a before and after example to really illustrate this?
Sure. Imagine trying to decipher code where the variables are named like A1, A2, A3, and so on.
Oof. Yeah, cryptic. Not very helpful.
Right. But now, what if those same variables were named like source, destination, and so on? Suddenly the code starts to make more sense.
It's like you flipped a light switch on. Just by changing those names, I immediately grasped what those variables represent.
Exactly. And it's not just about clarity. Martin also talks about this danger of disinformation, where you have names that sound plausible, but they actually mislead the reader. One example he gives is using Unix platform names like HP AIX or SCO as variable names in your code.
So someone reading that code might think those variables are related to the operating system when really they're not. Yeah, that just seems like a recipe for confusion.
Exactly. And yeah, it might take a little more effort up front to choose those really good names, but think of it as an investment.
Right.
Those clear names are like signposts for anyone who has to read your code in the future, including yourself.
Oh, for sure. It's easy to fall into the trap of using cryptic names, especially when you're kind of in the zone, just trying to get the code working. But I can see how that upfront investment in good naming would pay off big time later.
Absolutely. And once you've got a handle on meaningful names, let's move on to another crucial aspect of clean code: functions.
All right, functions. Hit me with the wisdom. What's the clean code approach to writing functions?
The key here is keeping your functions small and focused. They should do one thing well. Think of it like a chef breaking down a complex recipe into manageable steps.
Okay, I can get behind that. I do love a good cooking analogy.
Right. And Martin actually uses this great example from Kent Beck. Beck wrote this program called Sparkle, which is, it creates those, magical shimmer effects you see in fairy tales. Anyway, Martin was struck by how small all the functions were in Beck's code, like just a few lines each, and each one was crystal clear in its purpose.
So our functions should be like those sparkle effects. Small, elegant, easy to grasp on their own. No more scrolling through pages of code just to understand what one function does.
Exactly. And speaking of making things easy to understand, minimizing the number of arguments a function takes is another important thing that Martin really stresses.
Fewer arguments. Okay. I can see how that keeps things cleaner visually, but sometimes you need a few ingredients to get the recipe right,
True, but just like with too many ingredients, right? Too many arguments can make a function really difficult to understand and even harder to debug. Ideally, you should aim for 0 arguments if possible. 1 is usually manageable, 2 might be necessary sometimes.
But more than 2, and you're entering the danger zone.
Yeah, pretty much. Martin gives a really clear example in the book. He compares right field name to right field output stream name. Which one of those is easier to grasp immediately?
Oh, that first one for sure. That second one, I'm already wondering, like, what is output stream even? Why do I need it?
Right, and that's the whole point. Fewer arguments lead directly to improved readability, which, as we've been talking about, is crucial for clean code. And speaking of readability, we should probably talk about how to handle errors in a clean way.
So we're talking about readability, and I feel like error handling is one of those areas where code can get really messy really fast. What's the clean code take on that?
Well, instead of relying on those cryptic error codes, the ones where you have to go hunting for their meaning somewhere else in the code base, Martin's a big advocate for using exceptions.
Okay, so instead of returning like a generic error code from a function, we would throw a specific exception that actually describes the problem in a more human-readable way.
Exactly. Think of it like it's like having this designated path for problems to flow through instead of having them scattered all over the place in your code.
Makes sense. So it's like leaving a clear trail of breadcrumbs for whoever has to come in and debug later, which, let's be honest, is often me trying to figure out what past me was thinking.
Exactly.
Hmm.
And speaking of debugging, how do we even keep our code clean when, inevitably, our projects start to grow in complexity? I mean, I've definitely seen code bases that start out all nice and tidy, and then as you add more features, deadlines loom. Well, things can get a little, shall we say, tangled.
Oh, tell me about it. It's like entropy in action. So how do we fight back against that? Does clean code offer any solutions?
It does. One of the big ones Martin talks about is this idea of refactoring, but not as like a separate phase, right? He emphasizes that it should be like a regular habit, something you're doing constantly as you're developing your code.
Got it. So instead of waiting until the code base is a complete disaster zone, we're constantly doing these small cleanups as we go along.
Exactly. It's all about making those incremental improvements to your code so it stays manageable.
That makes a lot of sense. Now, we can't talk about clean code without talking about clean tests, right? What's the approach that Martin advocates for?
He's a huge proponent of test-driven development, or TDD for short.
Yeah.
And the core idea there is that you write your tests before you write the actual code.
I'll admit that always felt a little backward to me. Like, how can I write a test for something that doesn't even exist yet?
It is a different way of thinking. But trust me, it can be incredibly powerful.
Yeah.
Basically, you start by defining what you want your code to do, which becomes your test. Then and only then, you go and write the code to actually make that test pass.
So it's like I'm setting the target first, and then I aim for it, which I guess is less daunting than building this whole thing and then trying to figure out if it even works.
Exactly. And, TDD comes with a bunch of benefits. For one, it forces you to really think about your code's design up front, before you get bogged down in all the tiny little details. And it also means that you're automatically building up this comprehensive suite of tests that are going to catch any errors as your code evolves over time.
It's like having a safety net, right? If I accidentally break something, my tests are going to alert me right away. But, Martin also talks about how it's not enough to just have tests. He says those tests have to be clean too. Why is that so important?
Remember that broken window theory we talked about earlier? Well, it applies to our tests just as much as our production code. If our tests are messy, if they're convoluted, they become really difficult to understand, maintain, and ultimately less effective at actually doing their job.
Right. Messy tests almost defeat the purpose of having tests in the first place, don't they? If they're hard to understand, you can't even be sure they're testing the right things.
Exactly.
Yeah.
In fact, Martin tells this great story about a team he worked with that was really resistant to this whole idea of clean test at first.
Oh no, how did that turn out?
Well, their argument was that any test is better than no test.
Yeah.
Even if it's a bit messy, just to get it done.
Oh, I've been there. Just get it to pass. We'll clean it up later. And I've learned that story rarely ends well.
It rarely does. And this team, they eventually realized that all those messy tests they'd written were actually slowing them down. Because they were so difficult to change or update, they basically became a liability.
So it's like saving a few minutes up front by just shoving things into a junk drawer, but then you waste hours trying to find anything when you actually need it. So clean tests, they're really an investment, not just a nice to have.
Exactly. And, this whole mindset of quality, it extends beyond just individual functions and classes, right? Mm-hmm. It also influences how we think about our system design and architecture.
Okay, so we're zooming out to the bigger picture now. Interesting. So what does clean code have to say about that? What does clean architecture even look like?
Well, One concept that Martin brings up is the idea of domain-specific languages, or DSLs. It's kind of a mouthful, but
Yeah, break that down for me. What are DSLs all about?
basically it's about creating a mini language, if you will, within your code that's specifically tailored to the problem you're trying to solve.
So instead of using these generic programming constructs that might not really fit the domain, you're creating something that's more expressive, more tailored to the problem at hand.
Exactly. Think of it like having a set of specialized tools for a specific job.
Yeah.
And, this actually ties back to what you were saying earlier about wanting to learn efficiently.
Yeah.
DSLs can make your code much easier to not only write, but also to understand and maintain.
Because you're not just writing code, you're communicating ideas in a way that's clear to everyone working in that specific domain, right?
Precisely. And speaking of efficient learning and system architecture, remember TDD.
Yeah, we talked about it earlier, but for individual units of code.
Right. Right. But we can apply that same TDD mindset to the entire systems architecture.
Yeah.
So instead of trying to create the perfect architecture on day one, which, let's be honest, is practically impossible.
Oh, I know it. I've tried. It's like you end up down this rabbit hole of trying to plan for every possible future scenario, and it gets overwhelming fast.
It really does. So instead of aiming for perfection right out of the gate, we can use TDD to start simple and allow that design to kind of emerge organically as we go.
So we're building a solid foundation and adding to it in this really controlled, iterative way, guided by our tests.
Exactly. It's like building a house. You start with one brick at a time, but you make sure that each brick is placed correctly and it supports the overall structure as you go.
Wow, this has been really eye-opening. We've gone from talking about tiny variable names all the way to the big picture view of system architecture. And it's all connected by this theme of clarity, keeping things clean and easy to understand.
Yeah. And to be clear, clean code, it's not really about following rigid rules. It's more about cultivating a mindset, approaching your code with this sense of craftsmanship, and constantly asking yourself, how can I make this better?
So it's a journey, not a destination, which honestly, for those of us who are always learning and, iterating on our code, that's kind of a relief.
It is. And the book, it's full of these really practical tips and tricks that you can start implementing, like today, in your own code.
You mentioned earlier that he has a whole section on smells and heuristics. Are those red flags in your code that tell you something might need a little attention?
That's exactly what they are. It's like having, it's like having a code doctor on call.
Yeah.
Right? They're there to help diagnose potential problems and then give you solutions to fix them.
Okay, I love that analogy. So as we wrap up this deep dive into clean code, what's one key takeaway you hope our listeners walk away with?
If I had to pick just one, it would be this. Writing clean code, it's a form of respect. It's respect for your fellow developers, respect for your future self, and ultimately, it's respect for the craft of programming itself.
That's a great way to put it. And I think when we strive to write clean code, it shows that we care about quality, that we're really invested in building something that's not just functional, but also, a pleasure to work on.
Exactly. It's something worth striving for, wouldn't you say?
Absolutely. So to everyone listening, as you go forth in code, remember the principles we talked about today. Embrace the challenge of writing clean code because it really does make a difference. And never stop learning and refining your craft.
Hear, hear. Happy coding.
Happy coding.